today we will be solving find the count of numbers which are not special. So for this particular problem, it's a bit tricky one. First, we'll go through the problem statement, what the problem statement says to us, and then we shall go ahead and see whether we can solve it or not. Okay. So you are given two positive integer left and right, L and R, for any number x, all positive divisor of x except x are called the proper divisors of x. Okay, a number called special if it has exactly two proper divisors. So the thing is that over here we have to give give the count of numbers which are not special. Okay, and the problem has specified a special number as that number which has exactly two proper divisors. So what is a proper divisor? All the positive divisor except the number itself is the proper divisor. For example, 4 is considered to be special because it has proper divisors 1 and 2 only. 6 is however not considered special because it has proper divisors 1, 2 and 3. So you might be thinking, well, isn't it that easy? Like we'll just run a loop from left to right, and then for each number we'll find out all the positive divisors. If the count of the positive divisors for that given number exceeds 2, then we shall just uh, return false from that, and we won't count those numbers as specials. Okay, and then what we'll do, we'll just, the idea is basically to calculate the number of special elements, and then after that, from the total numbers of element, those which came special, we'll refer them as non-special, and that would be my answer. So the problem with that approach is that it would give TLE, time limit exceeded, because that would be a very bad approach. Like term complexity wise, we are going through, it would be around n square only. First we are going to L to R, then for every number we are starting from 1 to n by 2 that number. So it's around n square. Okay. So we'll have to think for a better approach. Okay. So if we dig a bit deeper into this problem, we will realize one special detail about this. Okay, see over here, number 4 is special because it has proper divisors 1 and 2. Hmm. The last divisor, which is 2 over here, is a prime number, and the square of that prime number is a special number. Okay, but over here 3 is over here, it's not special. Okay, so after carefully looking and analyzing, what I came up with an observation for this particular problem was this, that the square of the prime numbers square of the prime numbers are the special number. Not every prime number. Like for instance, in the case of 3, it won't be a special number, but it at some instances it would be. So we'll have to carefully check. Okay, so what we can do is, first in left to right, like over here, if you see this example over here, 4 to 16. Okay, so 4 to 16, we can do one thing. mm, we'll find the square root of 4 and we'll find the square root of 16. Okay, which would give me 2 and 4. Between 2 and 4, I'll find all the prime numbers. Okay, between 2 and 4, I'll find all the prime numbers. Then what I'll do, I'll square those particular prime number and check them whether they are in this range or not. If they are in this range, then it means yes, that is a special number. Okay, like that we can do. Instead of just going through the running the loop from 1 to that particular number, counting the number of divisors, instead of doing that, we can do it this way first. But you might be wondering, okay, we'll have to check prime numbers, then it again comes back to being square one. I would say why? because prime number will have to again run a loop from 2 to n by 2 and check number of divisors. If there are no particular divisor between this range, then I would say it's yes, you can do that way, but that would also give me TLE. So there is a different approach for this. It is called sieve of Eratosthenes. I would write it over here. Sieve of Eratosthenes. This, if we go via this approach, sieve of Eratosthenes, it would ensure that the time complexity is bit less. Okay, and it is better. Using this approach would be better. What does this approach tell us? Okay, so this approach asks us, I'll just give you a brief idea over here first, and then I'll, while coding alongside, I would explain. When I use this approach basically tells us to make us a Boolean array. This is, see, first of all, I'll just write a description over here a bit as well. This approach helps us to know all the prime numbers from 0 to a particular number. So if you are asked that from 0 to particular number, tell me how many prime numbers are there or list the prime numbers. I would use the sieve of Eratosthenes method. And this is very easy. It's not that difficult. I'll tell you what I'll do. For this, I'll have to create a Boolean array from 0 to n. Okay, I know the first prime number in mathematics, the first prime number is 2. So all the multiples of, first I'll set every number to be true, considering every number is a prime number. I'll start off with 2. I know that 2 is a prime number. Okay, I'll set the multiple of every multiple of 2 to be false. Okay, so basically I have removed all the numbers. Basically I have removed all the numbers which are composite and multiple of 2s. Okay, so that way I'll keep continuing the same procedure, and until the end I would get all the prime numbers from 0 to n. Okay, now let's start coding a bit. So first my thing is that I'll make a left and right. Okay, so I'll write int left, which should be int, and then I should write math dot sqrt of left. Okay, then I shall write right over here as well. Right equal to int of math dot sqrt right. Okay, so I've got my left, I've got my right. Okay, on which I'll be looking for the prime numbers, the range. Okay, now I'll simply create a Boolean array. Boolean, let's say primes, and let's name it primes, new Boolean, and I want the size to be right plus 1. Okay, now that I have this, because right plus 1, why? Because I want to have 0 as well. Now I'll have a loop control variable as 0. I'll set every mm, number to be 0. I shall wait. This is a better thing to do. Okay, this way. And I'll set primes of I equal to true, not false, but true. And it should be I plus plus over here. Yeah, let's remove the brackets as well. No need of making the code a bit longer. Now what I'll do is that I know that 0 is not a prime number, so I'll myself just make it false. And similarly, I also know that 1 isn't a prime number as well, so I'll set it up as false as well. Okay, so let's just make it right. Okay, because I know it is going to be till right only. We want it to be from 0 to right. Okay, now it's okay. Now what I'll do is, once I've set every element to be true, now I'll run the loop again. This time I shall set it from 0, while I is not equal to, or I is less than equal to right, rather I shall check if primes of I is equal to true? Yes or no? If it is true, then what I want to do, set all the multiples of this prime number in my range, I go to be false. Okay. Yes. Now what I shall do is this. Wait. I'll have to take another variable. So I'll take variable over here and I shall start. For j is equal to I square, j less than equal to right, and j plus plus. Once I have done this, uh, what I'll do, no, not j plus plus, I want the multiple. So j is equal to j plus I. Yes, this is better. Now I shall set just primes j to be false. Yes, let's remove this as well. And after that I just want I plus plus. Yeah, that is pretty much good. Now I have my array which contains all the primes and non-primes marked as true and false. Okay, so what I need to do is that I'll set I equal to left. From left I'll start. Okay, and while I is less than equal to right, I'll select those numbers which are prime. So if primes of I is equal to true, now I know that these numbers are prime. Okay. Once I know they are primes, I'll check whether the square of those numbers are in my range or not. So I'll just write if I square is less than equal to left and I square is greater than equal to right. If that is the case, I'll have my uh, special counter over here, set it up as 0, and I'll come over here once, and I'll just ensure that special gets incremented once. And if that's not the case, just move forward. Now I have my special. Now I'll just need to do one thing. I have to get all the numbers from 5 to 7. Okay, so it is like 5. Like 5 is one number, 6 is another number, 7 is another number. So there are total of 3 numbers. So what should be the formula for that? Right minus left plus 1. Okay, so right minus left plus 1. And from those total numbers, I need to remove the special number. So I'll remove the special number. This should give me my result. I hope. Let's see. Hmm. Okay, there are some sort of issues over here. Let's debug it a bit. Where I have got wrong. Malloc sqrt 4 6. I'm getting 13 over here. Wow. Instead of 11. So yeah, special is 0. Primes of I square is less than equal to L, and I square greater than equal to R, I plus plus. Let wait. Oh, hmm, what if I make it true over here? Let's see. Still the same result is coming. Yes, it is coming 13. So it's like 16 minus 4. So it is special is not increasing. So there is some sort of problem with the special over here. Uh, Primes of j is I square, j is less than equal to right, and j plus plus, j is equal to j plus I. Okay. Mm, mm. Oh, over here it is a blunder of a mistake. What have I typed over here, man? It should be greater than equal to L, less than equal to 0 R. So now it should work. Hopefully, let's see whether it works or not. Finally, yes. Let's go. Let's go. Let's go. Let's go. Let's go. Mm, yes, it gets accepted. So over here there was a minor mistake while typing. It should be basically between the range of L to R. So what I have written was, it was outside that range. No, I want it within that range. So yeah, this is the code. Hopefully, I hope that you guys have understood the problem. Okay, see you in the very next one. Till then, bye bye.